I am recording Thursday, March 24th, 2016, and I'm going to do a lesson on 9-5 in our geometry text. Starts on print page 374, and in your Braille volume 35, I would like you to start a couple pages in on Braille page 3, and it would be P 374. So it's in this Braille volume 35, P 374, or Braille page 3. And we're starting on theorem 9-6. On print, you'll see the theorem in a box, and it says theorem 9-6. This whole section, triangles and parallel lines, is actually information you've done when you've studied parallel lines and triangles. And what it is the converse of a couple of theorems that you've already proven and deduced. And the theorems of parallel lines going through triangles and creating similar triangles. You're now going to do the converse and prove that the line going through the triangle is parallel to the outside by looking at the proportionality. So that's what theorem 9-6 shows. It says if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. So hopefully that sounds familiar, that it's the converse of the theorem we learned about proportionality once that segment happens, going through our triangle, creating a proportional segment. So they just show you a triangle with vertex A at the top, D at the bottom left, E at the bottom right, a line segment going through your triangle parallel to the base, BE, is labeled BE, and it's just reminding you that if AB, down below the triangle, it's reminding you if AB is to BD as AC is to CE. So another, the proportion AB over BD equals AC over CE, then you get to state that BC is parallel to BE. So the converse of what we've been doing. So you're going to do some problems where you look at the proportionality of either the segments or the sides. You could take the side of the triangle AB, triangle ABC, and you could compare it to the big side AE, and then take the other right side AC of the little triangle and compare it to the big triangle AE. If that's proportionate, you get to say that BC is parallel. So you're just looking for that proportionality to prove that segment BC is parallel to BE. So you're going to practice that in several problems in the homework. For example, we can go practice it on the next page with an example. So example 1 on the next Braille page, or just right below on the print page. There's a huge tactile up towards the top of the page, and they have some information going on with this triangle. They tell us in words that up at the top, determine whether segment TU is parallel to segment RF. So we've got a triangle you're looking at. S is the top vertex. R is the right vertex. B is, R is the left vertex. I'm sorry. B is the right vertex. And then there is a line segment going through our triangle at about the 2 o'clock to 8 o'clock position. And it's going from U to T, and find all of those. They've given you some measurements. You go up to the top side, SB. It's split into two segments. SU is 4 units, and U is 8 units. And then down at the bottom side, R to T, they are giving you that that's 5 units. And then they're sectioning off with a little braid going all the way, curving all the way from R to V, and telling you that the entire R to V is 15. So we need to prove if TU is parallel to RS. And so we're going to use the converse theorem that we learned the theorem about parallel lines and similar triangles are proportional and segments are proportional. Now we're going to flip it and see if our segments or similar sides are proportional. Then we know we can say without a doubt TU is parallel to RF. So we could do this a couple ways. We could say, well, I could look at 4, SU is 4, compared to UV is 8. I could set up a fraction 4, 8. And then I could look at RT as 5, and then I could figure out what is TV. Now, they don't tell me what segment TV is, but they do tell me the entire side is 15. So with some basic subtraction, I would know 15 minus 5, T to V is 10. So 5 to 10. Oh, if I simplify that, that's 1/2. If I simplify 4 to 8, that's 1/2. If I decided to compare it backwards, if I said 8 to 4, 10 to 5, 2 over 1 is the same as 2 over 1. That's one way we could prove it. Sure enough, they're proportional, therefore UT is parallel to SR, or vice versa, TU is parallel to RF. Or I could do side to side, because I have my small triangle, UTV, and my big triangle, SRV. I could say, okay, my top side of my little triangle is 8, and the top side of my big triangle is 12, because I have to add 8 and 4 together. So therefore, UV corresponds with SV. So UV is 8 to 12. And then down at the bottom, PV, I did some subtraction, and I know that's 10. I'm going to compare that to 15. That corresponds to the whole big side of the big triangle, 15. So 12 is to 8, or 8 is to 12, however you want to say it. To say it in the same way, 15 is to 10, or 10 is to 15. When we simplify that, we end up with the same ratio. We got 8 to 12. We could divide both by 4, and we'd get 2/3. And then we'd have 10 to 15, divide both by 5, we'd get 2/3. We could also cross multiply. Multiply our extremes, see what that equals. Multiply our means, see what that equals, and if they equal each other, it's proportional. In this case, we had 8 to 12. Does that equal 10 to 15? So, okay, 10 times 12 is 120. 8 times 15 is 120. Sure enough, it does. So they're proportional. Therefore, UT is parallel to SR. Okay? So you'll have several problems in the Check Your Understanding section that have you look at different triangles with lines going through them and proving whether that line is parallel or not. And you just check the proportionality. What you have to be careful is doing your basic math. That 15 on that bottom side of this problem, we had to know that then 15 minus 5 makes that P to be 10. Then we have all the numbers we can work with. All right? Turn several Braille pages and we'll go to the next interesting concept, which is on B375. B375, and it's Braille Page. And what's interesting about this is let's look at our tactile and we're going to deduce what's going on here. So we're just going to take the picture and we're going to think about what the next theorem is going to be. So we have a top vertex P, a bottom left vertex Q, and a bottom right vertex R. And going through the triangle is a segment parallel, it looks like parallel to QR. We can prove that based on our last theorem. The line is ST. And then they've given us some measurements. P to S is 5 units. S to Q is 5 units. Oh, interesting. P to T is 7 units. And T to R is 7 units. Oh, that's interesting. So we can then make the conclusion based upon information that we already have learned that S and T are midpoints, aren't they? Because they're splitting the side PQ in half, 5 and 5, and splitting the side PR in half, 7 to 7. They have equivalent ratios. 5 over 5 does equal 7 over 7, doesn't it? 5 over 5 is 1, 7 over 7 is 1. So then we go, oh, okay, I could figure out the value of ST if I knew the value of QR, or vice versa. I could figure out the value of QR if I knew the value of ST. Because notice if we think about the little triangle PST compared to the big triangle PQR, you know they're similar. The left side is 5 in relationship to the left side 10 of the big triangle. 5 is to 10, right? As 7 is to 14. 1 is to 2 as 1 is 2. Or 5 is half of 10. 7 is half of 14. We just proved or noticed that ST, if it hits the midpoint, it is half of what QR is. So segments that are parallel to opposite sides and intersect at midpoints of the side will always be half of the side opposite. So kind of hopefully makes sense because it's midpoint, and midpoints are half. So it should kind of logically, oh, okay, yeah, half, that would make sense. And then if we even prove it looking at the ratios, 5 is to 10 as 7 is to 14, oh, well then if ST is 8, QR would have to be 15, or whatever numbers they would give us. So that's the next theorem. It's on the next Braille page C, 375, on Braille page 9. It's in the middle of print page 375. They just say in words, if a segment joins the midpoint of two sides of a triangle, then it is parallel to the third side. We know that because it's created equivalent ratios of those segments. Then, and its measure equals 1/2 the measure of the third side. And we just proved that doing the math. There's no other way for it to do that but be half of it. It creates a 2-to-1 ratio. Big triangle 2 times the little triangle, where the little triangle is half of the big triangle. So they give you a basic ABC triangle, the line going through the midst of it parallel to the base. It's a segment CE. They show tick marks on the sides to show that it's being divided, the side is being divided in half. And then they give it in words that if they're midpoints, then AB and E is the midpoint, and AC, and then DE is parallel to BC, and DE is half of BC. So DE will equal 1/2 BC. So taking the information you've learned already about midpoints, about proportionality, about parallel lines, doing a little bit of math, now we come up with another if-then statement. If I've got a segment parallel to an opposite side that hits at the midpoint, I know that that segment is half the opposite side. You're going to have several problems where you're going to have to determine measurements of that segment or the opposite side of it. You also may have to determine measurements of the side that's being split in half. So it's pretty basic math. You have to either divide by 2 or multiply by 2. So let's go practice that in the next example 2, which is on E375 in Braille, or Braille page 11, and it's at the bottom of print page 375. Let's take a look at this drawing. It's very interesting, but then hopefully it will all start to make sense. We'll read the givens that they gave us too. You're going to notice that there's a huge triangle. The top vertex is U, the bottom left vertex is V, and the bottom right vertex is W. And then there's a triangle. There are 3 segments inscribed inside our big triangle that connect to make another triangle. And in fact, it ends up making 4 triangles. And they connect at X, Y, and Z. So X is on the far left, between U and B. And you go straight across, following that line straight across to Y on side UW. And then from Y, you go down at an angle, like from 2 o'clock to 8 o'clock or so, or 1 o'clock to 7 o'clock. You hit C between B and W at the bottom. Then you go back up, follow that back up to X. You're being given that X, Y, and Z are midpoints. So that's where you go, oh, a bunch of things to click in. Midpoints mean it's splitting my sides in half. Midpoints mean that it's creating proportionality. Midpoints mean that the lines that are parallel to the opposite sides. And midpoints mean those segments are half of the distance of the opposite side. And what also hopefully you're noticing is that it created 4 triangles that when they're put in the same position, they're all congruent to each other. And remember, similar triangles or congruent triangles always have the same corresponding angle measures. So they're going to have congruent corresponding angles. So this drawing just kind of very busy and points all that out, but stay very careful between midpoint and the segment. You should be able to make your way around it. So if we're being asked that B to W, so BW, all the way at the bottom, B to W, is 6A. It's a measurement of 6A. What is the measurement of XY? So you've learned now, you know that, oh, well, they gave me that X and Y are midpoints, therefore I know that I'm half of everything. So X to Y has to be half of W, half of 6A then would be 3A. So pretty simple. It might make you go the other direction and double it. All right. Okay. And then next, let's see, on the next page, they do an Algebra Link. If the measure of WZY equals 2B plus 1, so we're using that same triangle, but they're telling us an angle, 2B plus 1, and the measure of WVU would be what? Well, we know that they're parallel. They've created similar triangles, created corresponding congruent angles. So we know that the other angle would have to equal 2B plus 1. That's all there is to it. We would just repeat that angle measure because we know the angles are similar and or we know we've got parallel lines with a transversal, and so corresponding angles are going to be congruent. Right? So that is the entire section 9-5. I would highly recommend that you take a look at the Check Your Understanding problems on page 376. And I would do 3 through 8. And then on page 377, I would suggest doing 10 through 29. 10 through 29. And many of the problems are just going to be yes and no answers. Going to prove parallel lines with proportionality. And then several of the problems are going to be dealing with those midpoints and figuring out, is my segment double its opposite? Is my side double the segment, or is my segment half of the opposite side? Is my angle, are my angles congruent? And the measurements would be the same. So I would work through those problems, and you should have this section handled. Again, it's kind of a review section, really, of everything that you've learned. We've just done the converse, and we're utilizing it to prove things using the converse. All right, do good thinking, and we'll talk to you in the next video.